Stationary points are points where the gradient of the tangent will be 0. In other words, the derivative will be equal to 0 and the tangent will be horizontal to the x-axis. On either side of the stationary points, if it is a maxima, on the left the derivative would be greater than 0 and on the right it will be less than 0. If it is minima, then on the left the derivative will be less than 0 and on the right it will be greater than 0. It is also known as turning points or maxima or minima. So the maximum turning point, to determine that, all we have to do is equate the first derivative equal to 0 and solve for x. And use table of test points to show that the derivative on the left of the maxima is greater than 0. In other words, the function is increasing on the left and it is decreasing on the right. Minimum stationary points, once again we have to just find the derivative dy by dx, equate it to 0 and solve for x to get the x coordinate where the minimum occurs, and once again use table of test values to determine or to show that it is decreasing on the left and the function is increasing on the right of the turning points. Let's look at one example. This function over here, x cubic minus 3x squared plus 5, we're going to find the stationary points and then determine its nature. So there are two things. First, to find the position of the stationary point by finding the first derivative and equating it to 0 and solving for x. In this case, I get 3x squared minus 6x equals 0. When I solve for x, I get two values, two solutions. One of them is x is equal to 0 or x is equal to 2. These values are known as the zeros of the first derivative, also known as the critical points. Next, we have to determine the nature of these critical points. We carry out a test point. So we use the critical point 0 and 2 and choose an x value on either side of these values and find the first derivative or evaluate the first derivative to determine the sign. In the first case, if we have -1, it's positive gradient, and then at 0 it will be horizontal to the x-axis. When x is equal to 1, we have a negative gradient, and at 2 it is horizontal to the x-axis, and at x is equal to 3 we have a positive gradient. Therefore it shows us, or it tells us, that at 0 we have a maxima and at x is equal to 2 we have a minima. We can check our answer by using the second derivative. We evaluate the second derivative at those critical points. In this case, we see over here f double dash of 0 is less than 0, in other words negative. So we have a concave down. We have a concave down at this particular point, thus giving us a maxima. And when x is equal to 2, the second derivative is greater than 0, so the curve is concave up and we end up with a local minima.